Good morning to everybody. I'm Efrem Piccinini, a master's degree student in Teaching and Communication of Natural Sciences at the University of Bologna in Italy. And today I will present to you a learning path to raise high school student awareness about the plastics and bioplastics topic. A quarter of a century ago, the Danish group Aqua released its most famous song, Barbie Girl. In the first iconic chorus, they sang,
Life in plastic, it's fantastic.
Even if they were referring to the dolls, they were somehow prophetic. We now largely use plastics in our everyday life. Shoppers, packaging, bottles, all sorts of containers are made of plastic. And this material is fundamental also in other objects. For example, our phones. All the circuits and electronic parts are placed in a plastic structure. Also in the hospital, to comply with the hygienic standards, a lot of tools are made of plastic, syringes, masks, surgeons' and nurses' clothes, and many more. Plastics are a key material also in the automotive sector, for the car body and the bumpers, and in the fashion industry. A lot of shirts are made of polymeric fibers. How come this material is used in so many objects? Its main advantages are lightness, a low cost of production, and the good resistance to heat, corrosion, and degradation. In particular, the possibility of modulating mechanical and thermal properties has made plastics suitable for a lot of different applications. They can be used for flexible, rubbery elastic bands and for hard, resistant plexiglass walls, used, for example, in the aquarium. The combination of resistance and lightness is very difficult to find in other materials. For example, metals are resistant to heat but not to corrosion, and they're quite heavy. For this reason, in cars, a lot of parts are made of light plastics rather than heavy metals, and this allows to reduce the car's fuel emissions. Instead, in the food and drinks conservation, plastic packaging help to reduce food waste and stretch its shelf life. Unfortunately, this wonderful material carries also some drawbacks. The bigger one is related to our consumeristic lifestyle. Many plastic objects are single-use, have a short life cycle, and create a high amount of waste every year. Because of its persistence in the environment, plastic fragments are now polluting many ecosystems, first of all the oceans. In fact, plastic is broken down into smaller pieces, which float in the oceans as microplastics and create some garbage patches that unbalance ecological relationships. Last but not least, plastics are nowadays still largely produced from oil, a non-renewable source. These problems have to be dealt with. Banishing plastics and creating a plastic-free world is unlikely, because there is no other material with the same qualities. There is no magic solution which solves all the disadvantages. A multifaceted approach is then required. Above all, a consumption reduction is advisable, even in the short term. Furthermore, it is necessary to drop our linear economic model and shift towards a circular, sustainable, zero-waste economy. In this context, bioplastics are a promising alternative to conventional plastics. According to European Bioplastics, which is the association representing the interests of the thriving bioplastics industry in Europe, as declared on their website, bioplastics are defined as either biodegradable, which means they can be broken down into smaller parts, carbon dioxide and water, in the environment in less than 6 months, bio-based, which means they're completely or partially produced from renewable sources, or both. These characteristics help to reduce plastic persistence in the environment if biodegradable, and to reduce oil dependency if bio-based, pursuing some of the UN Sustainable Development Goals, specifically number 12, responsible consumption and production, and number 14, life below water. To introduce students to this complicated yet crucial topic, a pilot learning path was brought forward in the Raw Matters Ambassador Schools framework. It is made of three main steps. Firstly, some theoretical lessons to introduce the key concepts. Then, hands-on activities to increase the engagement. At last, communication of what they learned to other students and to the general public. The path was specifically addressed to high school students from 15 to 18 years old and was set up to achieve an increase in the interest and curiosity of the youngsters towards the topic. Other goals were to increase knowledge and stimulate creativity and critical thinking, so that the students will become responsible and active citizens in the future. In fact, schools detain a central role in the education of future generations, and raising awareness of social issues is very important for this purpose. Theoretical lessons were the first step, aimed to introduce students to some key concepts: polymers, the correlation between chemical structure and properties, recycling processes, comparison between the different plastics and bioplastic types, and so on. A focus topic was bioplastics, definition, characteristics, pros and cons, etc. The lessons included also some videos, infographics, and schemes to meet different learning styles and surveys and workloads to stimulate the interest. In step 2, 3 different experiments were performed by students: sorting plastics, iodine run, from expired milk to bioplastics. In the first experiment, the students separate 4 different plastics with 4 different densities. Knowing that the objects with a smaller density than the solution will float and the ones with a greater density will sink, different solutions at different densities are prepared. The first one is just ethanol, the alcohol used for house cleaning. 30 milliliters are measured and poured into a glass filled with the mixture of plastics. This solution has a low density. Anyway, one plastic can float and can be then sorted from the others. Polystyrene, used for example as a wall insulator. Once this operation is done, the second solution is prepared by adding 20 milliliters of water to the ethanol. In this way, the density increases and polypropylene floats, making it easily removable. This plastic is used in many packaging containers. The last solution is thereby prepared by adding another 30 milliliters of water to the previous solution. Now, high-density polyethylene, used in bottle caps, floats instead. It seems there is nothing more, but some transparent plastic pieces lie on the bottom. It's polyethylene terephthalate, used for plastic bottles, which can be collected by filtrating the solution with a strainer. Sorting plastics help to introduce the topic, demonstrating that plastics are a large group of polymers instead of just one material. It offers also links to talk about the recycling processes. The second experiment, iodine run, starts with a question taken from our daily experience. Why can we use polyethylene to make sparkling drink bottles? This activity aims to find an answer. Inside a low-density polyethylene glove, iodine gas is produced through a reaction between copper sulfate and potassium iodide. The glove is soaked in a starch solution. Iodine gas can pass through the polyethylene glove and react with the starch, changing its color from white to purple. The conclusion is that polyethylene is permeable to gases. In fact, sparkling drink bottles are made of polyethylene terephthalate. This experiment shows how the different properties and uses of plastics are related to their chemical structures. In the last experiment, expired or skimmed milk can be used to create a bioplastic by adding vinegar to a glass of heated milk. Milk caseins coagulate and cross-link, forming a polymeric structure. This reaction imitates a virtuous example of a sustainable circular economy process. It creates an alternative to fossil-based plastic from food waste. The third and last step of the learning path was the design and creation of dissemination products. The targets were peers, other high school students, and non-expert people. They developed surveys, presentations, edu-games. It is a very important step as students turn into active co-creators of knowledge. 32 students from 2 different high schools in Bologna, Italy, were involved in this pilot learning path. 2 surveys were conducted for the learning assessment. The first took place before the beginning of the path, to find out preliminary knowledge and misconceptions. The second one at the end, to assess acquired knowledge and concepts. The results of the final survey show that the main goals of the learning path were accomplished. The interest and curiosity of the students significantly increased. Only 25% answered they were much or very much interested in the topic before the path, versus 56% after the end. The students seemed willing to further investigate some issues, like the recycling process and the impact of plastic pollution on the marine ecosystem. Their knowledge on the topic increased as well. The question, bioplastics are always biodegradable, was answered correctly by 75% of the students after the path, despite only 36% before. This learning path offers the teachers some links with other disciplines: chemistry, biology, material science, environmental sciences, technology, active citizenship. Furthermore, active learning through lab experiments and educational games can help teachers to integrate this topic in school programs, making it more appealing and interesting for the students. In conclusion, this learning path can help students to get closer to the plastics and bioplastics topic, a central issue in our lives, and to find possible solutions, trying to look at the problems from different angles. At the end of this presentation, we would like to thank Alma Mater Studiorum, University of Bologna, and the National Research Council. The European projects Raw Matters, Ambassadorate Schools, and BioBack, preparing the creation of bio-based education centers. We would like to thank also the teachers and the students involved in this project. And last but not least, all of you for your attention.